Right. But they want ventilators. Italy wants ventilators. Spain wants ventilators. Germany wants ventilators. They're all calling for ventilators. Well, we're going to make a lot of ventilators.
It's a great opportunity to study a design of a professional ventilator. Let's go. This is the PB560 ventilator. Front view. Top view. Side view. Rear view. Bottom view. This port is used as a gas output port to which inspiratory limb of double branch patient circuit connects, while this port is used as a gas return port to which exhalation limb of double branch patient circuit connects. What is the double branch patient circuit? This is the dual limb patient circuit. This is the inspiratory limb. And this is the exhalation limb. This is an inspiratory bacteria filter. And this is a humidifier. While these are water traps. Then what are these two ports? This port is connected to the exhalation valve via this tube. This is the exhalation valve. A gas flows through this tube. To control the open-closed position of the exhalation valve, to allow the exhalation gas to go out, the exhalation gas flows through the exhalation limb. Then it flows to the exhalation valve. The lower port is connected to the patient via this tube to monitor the patient's pressure. This port is connected to a proximal pressure sensor inside the ventilator to measure the patient's pressure. When the pressure exceeds a certain value, the control system inside the ventilator closes. The airflow that controls the exhalation valve diaphragm to allow the exhalation gas to go out through the exhalation valve. Then a new inspiratory and exhalation cycle starts again. As I promised you, I will demonstrate the internal parts of the ventilator in this episode. Turbine, air inlet filter, turbine control PCBA, inspiratory block, low pressure O2 inlet, O2 solenoid valve, exhalation solenoid valve, Before demonstrating the other parts, let's explain how the previously demonstrated parts work together. The turbine draws in air from atmosphere. The air flows through the air inlet filter, which is a replaceable air filter. Then it flows to the turbine. The turbine control PCBA controls the turbine. The turbine has two inputs and two outputs. The first input is used to insert air from the atmosphere. The second input is connected to the oxygen solenoid valve. Which receives oxygen from the low-pressure oxygen inlet. The first output is connected to the inspiratory block. The second output is connected to the exhalation solenoid valve. To understand how the inspiratory block and the exhalation solenoid valve work, we need to demonstrate another set of internal ventilator parts.
Exhalation valve pressure sensor. Inspiratory flow sensor. Inspiratory pressure sensor. Proximal pressure sensor. CPU PCBA. Exhalation flow sensor. Exhalation valve. The CPU PCBA controls all processes of the ventilator. The CPU runs software program that receives two types of inputs. The first type of inputs is the electric signals received from the sensors. The second type of inputs is the data received from the control panel. The user can send data to the CPU via these buttons. The CPU processes the received data according to the instructions of the software program. Then it sends output electric signals to the actuators.
In this episode, I will explain the operation of the Medtronic PB560 ventilator. The clinician uses these buttons to configure the settings to be suitable for the patient. Then the ventilator becomes ready to start ventilation just when the clinician presses the start button. When the clinician presses the start button, the CPU begins sending control signals to the turbine PCBA and the oxygen solenoid valve to make a mixture of atmosphere and oxygen used in inspiration process. Then the inspiration gas starts to flow. Note that the inspiration gas flows through the inspiratory flow sensor to measure the inspiratory tidal volume. And the inspiratory pressure sensor measures the pressure of the gas. And the proximal pressure sensor measures the patient pressure. These sensors send signals to the CPU to monitor the gas volume and pressure. During the inspiratory phase, another output gas of the turbine flows to close the exhalation valve. The exhalation valve is controlled by the exhalation solenoid valve, which is controlled by the CPU. When the CPU decides to end the inspiratory phase and start the exhalation phase, it stops the airflow from the turbine and releases the air that is closing the exhalation valve. When the exhalation valve is open, the exhalation phase begins. In this episode, I will explain more details about the pressure sensors and how they are connected to the microcontroller. The ST10F276 microcontroller is used as a CPU of the Medtronic PB560 ventilator. You can download its datasheet from the description of this video. It has 8 ports. The sensors are connected to port 5. The pins of port 5 are the analog input channels of the analog to digital converter. This is a part of the Medtronic PB560 CPU circuit schematic. And these are the pins of port 5. These pins are connected to the sensors. In Medtronic PB560, we use ASDX001D44R for pressure sensors. You can download its datasheet from the description of this video. The circuit of pressure sensing is very simple. This is the pressure sensor. 220 nanofarad capacitor. 4.7 nanofarad capacitor. 4.7 kilo ohm resistor. 100 nanofarad capacitor. Pin 1, 5, 6, and 7 are connected to 5 volts analog reference. Pin 3, 4, and 6 are connected to 0 volt analog ground. Five of the 16 analog inputs of port 5 are outputs of the recently explained pressure sensing circuits. In this episode, I will explain more details about the flow sensors and how they are connected to the microcontroller. In Medtronic PB560, we use AWM3300V as a flow sensor. You can download its data sheet from the description of this video. The circuit of the flow sensing is very simple. The flow sensor has 3 terminals. 2 of them are connected to the power supply. The third terminal is the sensor output. The other components of the circuit are simple passive components. These are the performance characteristics of the flow sensor at 10 volts supply voltage. The maximum flow is 1000 standard cubic centimeters per minute. Its corresponding output voltage is 5 volts DC. In ST10F276 microcontroller, pin 37 is connected to 5 volts as an analog reference. And pin 38 is connected to 0 as an analog ground. So the analog input voltage range is from 0 to 5 volts. Each analog input pin of port 5 is connected to the anode of a low forward voltage high-speed diode. All cathodes of these diodes are connected to positive 5 volts, to prevent the analog inputs from exceeding positive 5 volts. In the previous episodes, I explained pressure sensing circuits and flow sensing circuits. If you didn't watch the previous episodes, please watch them now to be able to understand this episode. In this episode, I will continue port 5 analog inputs explanation. This input is connected to power supervisory circuit. This is the power supervisory circuit. And this IC is MAX690A. You can download its data sheet from the description of this video. Pin 4 of MAX690A is connected to port 5 of the microcontroller. According to the data sheet of MAX690A, pin 4 PFI input is power fail comparator input. When PFI is less than 1.25 volt, PFO goes low. The PFO and reset outputs of MAX690A are connected to pins 142 and 140 of the microcontroller respectively. The Watchdog output of port 2 of the microcontroller is connected to pin 6 of MAX690A. So I will explain more details about the Watchdog when I explain port 2 of the microcontroller. In the next episodes, I will explain the other inputs of port 5 of the microcontroller, then I will explain how to write the software program for the microcontroller, to read the port 5 analog input signals.
To receive a notification when I upload the next video, please subscribe and choose to receive all notifications from the Ventilators channel. And click like and share to publish Ventilators manufacturing knowledge. If you have any questions about ventilators, please write your question in a comment below.